Question 21 reads, a project coordinator at a banquet hall is given the task of arranging seating for an awards ceremony. The figure above shows the first three possible arrangements of tables and the maximum number of seats in each arrangement. If the number of seats in each successive arrangement is increased by 6 over the preceding arrangement, which of the following represents the maximum number of seats around n tables? So basically what this question is asking for is it's asking us to construct an expression for this scenario right here. And so before we even look at the answer choices, I want to highlight this number of tables and the number of seats in each of these arrangements and rewrite them. Well, n tables is 1 here, n is equal to 2 here, and n is equal to 3 here. And if I say s for seats, s here it's going to be equal to 8. Here s is equal to 8 plus 6, or if I just count it again, it's going to be 14. And s is equal to 20, 14 plus 6, right? 6 over the preceding, right? Arrangement. That's the difference between each of these. Well, one way to solve this question is just by plugging in these numbers n for these answer choices. And so that really just works out. And if I do, let's say, I'm going to use these values right here and plug them in. Well, if n equals 2 here, then the seats will be equal to 18, and that's wrong. We need 14, right? And it's going to be, if I do 2 into 3, well, 3 into 2, that's going to be, 3 into 2, that's going to give me plus 1. That's going to give me 2 into 6 plus 1, which is 7. And that equals 14. Okay, so B looks pretty good. We can't be too confident right now. 6 into 2 plus 1, so 6 into 3 is 18, so that's wrong as well. D, 6 into 2 plus 3, so 6 into 5, okay, that's 30, and that's wrong as well. Okay, so with just one these sets of data, I'm able to get our answer B. If this isn't really your way of doing things and you don't really like plugging in values, and I do recommend for this specific question to actually plug in instead of make your own, but it does make sense, this equation as well, because if I FOIL out the 2 right here of answer choice B, it becomes 6n plus 2, which is really a linear equation, right? And so this must mean that 6 is the slope or the rate of change and 2 is the y-intercept, if you try to think of it like that. And so the slope is the rate of change, and they already say that, 6, right? That's pretty good already. We already know that the difference between each of these arrangements is 6 seats, and that makes perfect sense. Well, the 2 y-intercept, well, if you try to imagine 0 when n is equal to 0, well, they say that each table brings 6 seats, right? Basically what that means. And so if I make an imaginary arrangement, let's say arrangement 0, okay, before the 1, then there are going to be 2 seats without tables, okay? Without any tables, there'll be 2 seats. That's our starting value. That is our y-intercept. And so that answer choice B makes sense. Anyway, I don't know how, without any tables, there will be seats, but the logistics don't work out. But our answer choice that best fits the scenario is B.